Before we do calculations, let's look at what a balance symbol equation tells us. In the balance symbol equation, the reactants are on the left and the products are on the right. The balance symbol equation also gives us the relative number of moles of reactants that react to form products. A ratio is a way to compare amounts of something. In the balance symbol equation, the substances are in ratios, and the balancing numbers, which are the numbers in front, or sometimes referred to as the stoichiometry, gives the ratio of moles that react together. So, for example, copper carbonate will break down to give us 1 mole of copper oxide and 1 mole of carbon dioxide. If I had 2 moles of copper carbonate, I would get 2 moles of copper oxide and 2 moles of carbon dioxide. If I only had 0.5 moles of copper carbonate, I would get 0.5 moles of copper oxide and 0.5 moles of carbon dioxide. Let's now look at a reacting mass question. Calculate the mass of sodium chloride formed when hydrochloric acid is added to 10.6 grams of sodium carbonate. To do these questions, the most important thing you're going to need is your balance symbol equation. So what I'm going to do now is pull out any information that has been given in the question. If I look at the question, I can see I'm being asked for the mass of sodium chloride and I've been given the mass of sodium carbonate. So my mass of sodium carbonate is 10.6 grams and I'm being asked for the mass of sodium chloride. In chemistry, we can't work with masses, so we have to work in moles. Therefore, I'm going to convert my mass to moles. And to do that, I need the relative molecular mass of sodium carbonate, which is 106. I now can get my moles, which are 10.6 over 106, which are 0.1 moles. The question has asked me about sodium chloride. From my equation, I can see I have a 1 to 2 relationship. So my ratio is 1 to 2. I don't have 1 mole of sodium carbonate. I've only 0.1 mole of sodium carbonate, so I'm going to get 0.2 moles of sodium chloride. However, the question didn't ask me for the moles, it asked me for the mass. If you remember, our equation is moles equals mass over RMM. Therefore, our mass is going to be our moles multiplied by the RMM. If I work out the RMM of sodium chloride, it's going to be 23 and 35.5, which is 58.5. So 58.5 multiplied by 0.2 gives me 11.7 grams. If I look at this calculation, it is sometimes referred to as a Mr. calculation. The reason being, on the left-hand side on the table, I have MR, and that sometimes helps you remember the different steps in the calculation. Let's look at another example. This time calculate the mass of carbon dioxide produced by reacting 5.3 grams of sodium carbonate with hydrochloric acid. Let's use Mr. to help us structure the question. M stands for mass. In the question, we have been told we have 5.3 grams of sodium carbonate and we're being asked the mass of carbon dioxide. We don't work in masses, we work in moles, so R stands for the RFM, and in the case of sodium carbonate, it is 106. Then we're going to calculate the moles. The moles are going to be 5.3 over 106, which are 0.05 moles. From the equation, the ratio is 1 sodium carbonate to 1 carbon dioxide. We only have 0.05 moles of sodium carbonate, so we will get 0.05 moles of carbon dioxide. However, the question asks you to calculate the mass of carbon dioxide. If we think about the formula we use in this topic, moles equals mass over RFM, we can rearrange it to say that the mass is going to be the moles multiplied by the RFM. If we work out our RFM of carbon dioxide, it will be 12 plus 16 plus 16, which is 44. So the mass will be the moles, which are 0.05, multiplied by 44, which gives us a mass of 2.2 grams.